Greetings and welcome to Earth Uncovered, where science isn't rushed and curiosity lingers in the depths. Tonight, we set aside cosmic origins and distant futures to ask a quieter, more intimate question. One that begins beneath our feet. What if humanity isn't Earth's first act? Not its first architects, philosophers, or explorers. Picture an era before the pyramids cast shadows, before satellites crisscrossed the sky, even before the glow of late-night documentaries. Could this planet have nurtured another civilization? One that blossomed into complexity, only to vanish without a whisper? I'm not speaking of Atlantis or interstellar visitors. Imagine a native intelligence, biological, perhaps utterly alien to our understanding, that thrived and perished so long ago, Earth itself has erased their memory. Sounds like science fiction. And yet, this hypothesis has simmered for years in the back halls of geology departments and astrophysics conferences. We won't uncover chrome skyscrapers in Antarctic ice or iPhones trapped in shale. The truth would be subtler. Here's the real puzzle. If a sophisticated society existed 100 million years ago, would any trace remain? Could cities, tools, even language survive geology's slow churn? Or would time grind them all back to dust, leaving no seam between artifact and bedrock? But before we dig deeper, tell me this: where are you listening from right now? And what does the clock say where you are? There's poetry in it. We're discussing civilizations lost to epochs. Yet here we are, sharing this sliver of time across continents. And yet here we are, connected across continents and time zones, sharing this fleeting moment in the grand sweep of history. Whether you're listening under a noon sun or midnight stars, your presence matters. If these slow-burning questions ignite your curiosity, consider tapping that like button or subscribing. It's how this humble signal finds its way to other wandering minds. No obligation, just an open door, like the faintest fossil imprint, waiting to be noticed. Now get comfortable, lean back, let your thoughts drift as slow as continental plates. We're about to journey backward, not through human chronicles, but through the molten whispers and stone-carved silences of deep time. Because before we can ask, were we first? We must grasp the sheer scale of time we're dealing with and Earth's ruthless talent for erasing its own past. When we say ancient history, we usually picture pyramids, Stonehenge, or cuneiform tablets. But even humanity's oldest stories, stretching back 12,000 years, are a blink in geological terms. Closer to us now than to the planet's primordial dawn. And yet, that sliver of time already feels impossibly distant, shrouded in enough mystery to fuel centuries of debate. But Earth doesn't measure time in millennia, counts in billions. For 0.5 billion years, to be approximate. For nearly all that eternity, there were no cities, no mammals, no footprints on land. Life existed as whispers in tidal pools, microscopic, patient, rewriting the rules over eons. What seems like emptiness was actually the planet's most dramatic act, the silent, relentless drafting of Earth's epic. Time doesn't just pass here, it sculpts. Layer by layer, rock by rock, Earth writes its story in fragments, then burns the pages. Wood rots, metal corrodes, bones turn to dust. This isn't passive decay. It's planetary metabolism. Mountains surge and collapse. Oceans gasp wide before vanishing. Continents waltz, collide, and divorce. Every 300 million years, the world reinvents itself entirely. Survival isn't just unlikely, it's a miracle. So let's play with fire. What if 100 million years ago, after dinosaurs claimed the stage but before their final bow, another intelligence flickered to life? Not human, not even mammalian. Perhaps it walked upright or swam, built not with steel, but with materials we'd fail to name. Maybe its technology left no footprint. Maybe it thrived, crafted something akin to culture, then vanished, snuffed out by catastrophe or the slow suffocation of time. Now here we stand, millennia later, whispering, would we even know? Here's the uncomfortable truth. Humanity's monuments are ephemera. Skyscrapers crumble to vines in centuries. Highways dissolve into prairie grass. Given 1,000,000 years, tectonics shreds the evidence. Land becomes seabed. Mountains become sand. Our existence reduced to a hypothetical layer in some future geologist's core sample. This isn't speculation. It's geology's cold verdict. Even traces of recent prehistoric humans are vanishingly rare. Not for lack of activity, but because Earth is a relentless recycler. Take fossils. Their scarcity doesn't reflect life's scarcity, but the lottery of preservation. Most organisms die, dissolve, and leave no ghost behind. Decay is the default. Organisms decompose. Scavengers scatter them. Chemistry dissolves them. Fossilization isn't destiny. It's a cosmic lottery ticket. You need rapid burial, mineral infusion, and geological amnesia. Then pray the rock survives erosion, uplift, and discovery. Multiply those odds across 100 million years, and the silence starts making sense. But bones are just the beginning. Imagine their tools, their cities, even metal rusts, plastics ultraviolet into oblivion. Concrete, that symbol of permanence, eventually powders like chalk. If a civilization avoided megaliths, if it built with ephemeral materials, its entire existence might leave no more trace than a morning mist. Has science taken this seriously? Absolutely. In 2018, astrophysicist Adam Frank and climatologist Gavin Schmidt published a landmark paper, not claiming proof of lost civilizations, but asking, how would we know? They dubbed it the Silurian hypothesis, a playful nod to Doctor Who's prehistoric reptilian thinkers. Their real question was forensic. What fingerprints would an industrial society leave in rock strata after 100 million years? They hunted chemical ghosts, carbon spikes from mass combustion, synthetic molecules with no natural origin, rare element clusters hinting at mining. Think of it as detective work without a corpse. No artifacts, no ruins, just the faintest stains on Earth's geological wallpaper. And their conclusion chills. Absence of evidence isn't evidence of absence. Civilizations don't vanish without some trace. Agriculture reshapes soil. Industry alters atmospheres. But Earth's crust is a palimpsest, scraped clean every 300 million years by tectonics. What if we're just reading the last page of a story where earlier chapters were erased? But fingerprints blur. If an ancient civilization had its own industrial age, would its climate signals linger in ice cores or rock strata? Perhaps, or perhaps not. Even our mark on Earth, the so-called Anthropocene, is being etched into geology now. Microplastics in seabeds, radioactive isotopes from Cold War tests, concrete veins in sediment. Future archaeologists, be they human or otherwise, might decode these layers. But for how long? 1,000,000 years from now, will our epic be a faint chemical hiccup in some deep-sea drill core, or just another unremarkable layer in Earth's recycling bin? This isn't hypothetical navel-gazing. It's stress-testing science itself, forcing us to ask not just what we find, but what's irrevocably lost. The geological record is a patchwork of erasures. Some eras fossilized pristine. Others are shredded by tectonics, drowned by rising seas, or pulverized into subduction zones. Over 70% of Earth's surface is ocean, a black box where entire chapters of history sink into abyssal mud. Even the seafloor isn't safe. Every 200 million years, oceanic crust plunges into the mantle, taking its secrets with it. So if Atlantis had existed not as myth, but as a Bronze Age port city, its rubble would now be mantle magma. Here's the paradox. We scan the cosmos for alien signals while rarely questioning if Earth itself might have whispered earlier. The past could be quieter than we imagine, or we've simply forgotten how to listen. Next, we'll dissect what can survive deep time, spoiler, not much, and whether we've already brushed against ghosts of civilizations past without recognizing them. The answers, like Earth's crust, are layered. We'll peel them one epoch at a time. Let's pause and ask the fundamental question. What even is a civilization? In modern shorthand, we picture skylines and hieroglyphs, but that's anthrocentric myopia. Human civilizations have ranged from Teotihuacan's grid of pyramids to the Inuits' icebound oral traditions. Archaeologists use a checklist of traits: cities or dense settlements, labor specialization, potters, priests, programmers, surplus agriculture, enough food to feed bureaucrats, symbolic systems, writing, art, currency. Yet exceptions abound. The Indus Valley civilization left no obvious temples. Catalhoyuk, a 9,000-year-old Anatolian hive, had no streets, doors, or monuments, just roof-to-roof homes. Its civilization status comes from collective fingerprints, ritual burials, grain storage, mural art. So for deep-time civilizations, we must widen the lens. Not did they build skyscrapers, but did they modify their world with intent? Not did they write, but did they transmit knowledge beyond individuals? Even modest benchmarks are revolutionary. Tools redesigned across generations, not just used. Landscapes altered for future harvests, not just seasonal foraging. Pigments mixed for ceremony, not just utility. Take ochre crayons from 100,000-year-old caves. Their existence whispers. We planned. We remembered. We believed. Civilization isn't an on-off switch. It's a spectrum between bare survival and Dyson spheres. And somewhere on that gradient, whether in mammoth bone huts or coral reef megastructures, complexity leaves traces. Technology isn't just silicon and steel. A 40,000-year-old bone flute is technology. Ochre mixing for ritual is technology. Any systematic application of knowledge, whether to carve antlers or encode quantum physics, qualifies. Now stretch that definition across 10 million years. What traces could remain? The preservation paradox. Built with organics? Wood, sinew, chitin vanished without a whisper. Buried their dead with flowers, not gold? Bones remain, meaning evaporates. Wrote on bark or water. Language dissolved faster than ink. Lived in rainforests, coastlines, swamps? Ecosystems that digest history. Time isn't just a filter, it's a demolitions expert. The anthropomorphic trap. We instinctively search for cities, but what if they nested in coral reefs? Tools. What if their machines were bioengineered fungi? Writing, could bioluminescent pulsing be their poetry? Absence of evidence isn't failure of imagination. A swamp-dwelling, mycelium-networked intelligence from the Carboniferous period wouldn't leave iPhones in strata, but maybe strange biomolecular patterns in coal. Anomalous root networks fossilized like neural maps. Spores arranged in geometric layers. The challenge isn't just finding needles in haystacks, it's recognizing alien needles as needles at all. The blind spots of intelligence. We equate civilization with our blueprint. Cities, texts, smokestacks. But intelligence could wear infinite disguises. A fungal network coordinating via chemical pulses across continents. A coral-like collective encoding knowledge in calcium carbonate patterns. A methane-based ecosystem where liquid crystal formations serve as art. The termite paradox illustrates this perfectly. To our eyes, a mound is just dirt. Zoom in, it's a megacity with HVAC systems, fungal farms, and distributed cognition. Fossilize it for 10 million years, and even that masterpiece becomes indistinguishable from a weathered hill. Detection beyond anthropocentrism. Future archaeologists, alien or human, wouldn't just scan for ruins. They'd hunt, microscope biomolecular oddities, stable isotope ratios in ancient mudstones suggesting mass metal refining, fossilized hyperuniform crystal clusters hinting at quantum computing substrates, globe showing Europe-Africa geochemical ghosts, sudden spikes in atmospheric lead without volcanic explanations, synthetic fullerenes trapped in Precambrian rock layers, hourglass not done temporal red flags, humanity's 300-year industrial spree already left, plutonium-239 in sediment, half-life 24,000 years, microplastic strata in oceanic basins, nitrogen cycle distortions visible in ice cores. Our footprint will outlast us by eons, yet it's just 0.00006% of Earth's timeline. The ultimate irony. The most enduring traces of civilization may be radioactive nuclear waste, ceramic-encased isotopes lasting millions of years, building construction concrete reefs, rebar oxidation patterns surviving subduction, oil drum fossilized petroleum byproducts, unnaturally refined hydrocarbons. Ironically, our pollution could become our most legible epitaph. A call for interdisciplinary sleuthing. To find predecessors, we must merge. Astrobiology's open-mindedness. What could intelligence look like? Forensic geology's rigor. Reading rocks as crime scenes. The answer may not be in grand ruins, but in a single anomalous iridium layer, or a strangely folded stratum whispering, "This was no accident." Time doesn't erase, it transforms. We measure our lives in seasons, but Earth keeps time in geological eras. What seems permanent, skyscrapers, highways, entire nations, is ephemeral against continental drift. Consider the three great recyclers. Weathering, nature's sandblaster. Rain dissolves limestone cities like sugar cubes. Freeze-thaw cycles pulverize granite monuments to gravel. Even titanium oxidizes to dust given 100,000 monsoons. Sedimentation, the planet's shroud. A single dust storm can bury Memphis deeper than the Sphinx. Volcanic ash preserves like plaster, Pompeii, or smothers like concrete, Toba eruption. The fossilization lottery. Only 1 in a billion organisms avoids recycling. Tectonics, Earth's conveyor belt. Himalayan peaks rise 1 centimeter per year. Your city could be seabed in 5 million years. The Pacific shrinks by a Tokyo-sized patch annually through subduction. Deep time irony. The very forces that destroy also preserve, e.g., high-pressure mineral replacement. The subduction when ocean plates dive into the mantle. Comet 99.9% of material melts into primordial soup. Magnifying glass tilted right 0.1% survives as ultra-high-pressure minerals, e.g. coesite. Gemstone rarest exceptions. Diamond capsules preserving billion-year-old carbon. Humanity's best shot at immortality. Our longest-lasting legacies may be oil drum petrified plastic veins in future shale. Radioactive plutonium forever glass in desert strata. Building construction concrete conglomerates surviving like Roman marine concrete. Subduction doesn't archive, it annihilates. Entire oceanic plates, along with whatever cities or civilizations might have thrived upon them, are dragged into the mantle's crucible where temperatures exceed 1,000 degrees Celsius. The math is sobering. With oceanic crust recycling every 200 million years, just 4% of Earth's history, any coastal or island civilization had about a 1 in 20 chance of leaving traces we might find today. Continental crust offers slightly better odds, but faces its own destructive forces. Kilometer-thick ice sheets during glacial maximums could polish Manhattan down to bedrock in 50,000 years. while volcanic supereruptions like Yellowstone's last event can bury continents under meters of sterilizing ash. Even apparent constants like the Grand Canyon's stratified timeline contain haunting gaps called unconformities, some representing over 1 billion years of missing history. The fossil record underscores this impermanence. Of all species that ever lived, less than 1% fossilized, and of those, perhaps 1% will ever be exposed and found. For cultural artifacts, the preservation lottery is even more brutal. A single Paleolithic wooden tool survives for every million that decayed. Our entire understanding of ancient humans comes from these statistical miracles. A 200,000-year-old ochre workshop in South Africa, preserved by cave collapse, or Catalhoyuk's mud-brick walls surviving thanks to Anatolia's arid climate. Now extend this fragility across deep time. A hypothetical civilization from the Jurassic would need 1. To avoid coastal habitats now subducted, 2. To build with materials resisting 150 million years of groundwater chemistry, 3. To leave traces in the 3% of Earth's surface that's both accessible and undisturbed. Even asteroid impacts, the most violent geological business cards, fade. The 300 kilometers Vredefort crater from 2 billion years ago is now just subtle warping in South African bedrock. The sobering conclusion? Absence of evidence becomes inevitable when the universe's most efficient recycling system, planet Earth, has been running for 4.5 billion years. Detecting ancient civilizations demands perfect storm conditions. Not just preservation but discovery. Consider, a 100-million-year-old city would need to survive subduction/erosion, then surface where modern researchers drill/core/excavate, using instruments calibrated to recognize artificiality. Most geological surveys hunt biomarkers or mineral deposits, not pavement fragments. Even when encountering anomalies, natural explanations dominate. That perfect sphere in strata could be a Paleolithic artifact or just a manganese concretion. Nature's complexity constantly deceives. Hexagonal basalt columns mimic architecture, fulgurites resemble manufactured glass, and banded iron formations mirror industrial waste. This explains the Silurian hypothesis' methodological pivot. Rather than seeking temples or tools, it tracks planetary-scale disturbances. Isotopic spikes in sediment layers, synthetic molecules in ancient rock, atmospheric aberrations in ice cores. Yet ambiguity persists. The PETM's 56-million-year-old carbon spike mirrors fossil fuel burning, but could also signal volcanic activity. Similarly, Ordovician heavy metal deposits might indicate smelting or just unusual hydrothermal vents. The core challenge? Earth's archive is both fragmentary and full of false leads. Our linear historical narrative collapses under geological reality where timelines blur and most data points vanish permanently. Conventional fossils exemplify this. Less than 0.1% of species fossilize, and those that do undergo permineralization that scrambles original chemistry. That pristine museum dinosaur? Likely composites from multiple specimens, minerals replacing bones cell by cell over millennia. True endurance requires either incredible luck, rapid burial in anoxic environments, or atomic-scale stubbornness. Think plutonium-244's 80-million-year half-life rather than pyramid stones. The most promising traces aren't megaliths but molecular ghosts. Synthetic isotopes, nanotechnology residues, or re-engineered biomolecules persisting in sedimentary layers. These could theoretically outlast mountains if we learn to read them. Our next task: decoding planetary palimpsests for signatures that even Earth's recyclers couldn't erase. Fossilization is nature's ultimate lottery, a statistical miracle requiring perfect alignment of death, burial, and geological stability. Even in ideal conditions, perhaps 1 in 10,000 organisms fossilizes, with far fewer ever exposed for discovery. The process is brutally selective. Marine creatures in anoxic basins stand better chances than jungle dwellers. Sudden mudslides preserve moments while slow sedimentation scatters them. What survives is often distorted bones mineralized beyond DNA recovery, soft tissues flattened into carbon smears, ecosystems represented by single lucky specimens. The famous Burgess Shale, our clearest window into the Cambrian explosion, captures just 0.0001% of that period's biodiversity. Now extrapolate this fragility to cultural artifacts. A stone tool requires identical preservation luck plus the added hurdle of recognition. Out of context, a 2 million-year-old Oldowan chopper resembles a frost-shattered rock. More complex technologies face worse odds. Imagine identifying a decayed polymer widget as artificial after 100 million years in shale. Even our most durable modern materials fail against deep time. Stainless steel corrodes to iron oxide within 25 million years in moist strata. Concrete recrystallizes into metamorphic rock after 50 million. The only potential exceptions involve atomic scale signatures, synthetic radioisotopes from nuclear testing, detectable for 100 million years, or nanotechnology residues with unnatural molecular patterns. But here we confront archaeology's central paradox. The very planetary processes that erase civilizations, subduction, erosion, metamorphism, also destroy the evidence we'd need to prove they existed. Our search resembles reconstructing an epic novel from random alphabet soup, possible in theory, but requiring unimaginable luck. Yet perhaps there's hope in extremophiles. We've found 250-million-year-old bacterial spores revived from salt crystals. If microbial life can persist through geologic eras, might some artificial molecular machines do the same? The answer lies not in grand monuments, but in quantum-scale anomalies, isotopic ratios that shouldn't exist, crystal defects that couldn't form naturally, chemical gradients too precise for chance. These atomic ghosts may be our only whispers from deep time. The archaeological record isn't just fragmentary. It's systematically biased toward the durable and the disastrous. Consider Homo erectus. Despite dominating Earth for 1.8 million years, 60 times longer than modern humans, we've recovered less material than from a single medieval garbage dump. Their stone tools survive while wood implements rotted. Campfire hearths persist where spoken languages vanished. This preservation bias creates false negatives. We mistake absence of evidence for evidence of absence. Mass extinction boundaries become informational oases not because life flourished there, but because catastrophic burial, volcanic ash, and anoxic mud created exceptional conditions. A civilization's best chance at fossilization? Perish en masse near a sedimentary basin during a flood basalt eruption. But intelligence tends to avoid such scenarios. We build flood walls, divert lava flows, develop warning systems. Advanced civilizations might actively prevent the very disasters that could preserve them. More troubling is the material progression hypothesis. As species technologically advance, they transition from leaving bony remains to creating ephemeral substrates. Imagine a culture that evolved beyond biology, storing consciousness in quantum arrays or distributed nanotech webs. Their artifacts would be unrecognizable. Perhaps subtle distortions in Earth's magnetosphere, or anomalous heat signatures in ancient rock layers. Even if we excavated a functioning 100-million-year-old quantum computer, would we recognize it as anything more than an odd mineral formation? The fossil record filters not just by durability but by our own perceptual limits. We find hand axes because we understand hands. We miss technologies operating on scales or principles beyond our ken. The ultimate irony? A hyper-advanced civilization might leave planet-sized engineering signatures, rearranged solar systems, Dyson spheres, while leaving precisely zero traces in sedimentary rock. Their absence from strata wouldn't prove non-existence, just our inability to read the universe's deeper documentation systems. Our civilization's true signature lies not in grand monuments but in atomic alchemy. We've redistributed Earth's elements in ways nature never would. A future paleontologist might encounter strata laced with synthetic isotopes, plutonium-239's 24,000-year half-life, nanoparticles from catalytic converters, and sudden spikes in rare Earth elements, all clustered in a geological instant. Yet, without context, these anomalies could be dismissed. The titanium layer as meteoritic dust, the polymer residues as bizarre kerogen. Interpretation is everything. When 20th century archaeologists first encountered naturally formed spherical stones in Costa Rica, they cataloged them as ancient artifacts until geology revealed their volcanic origin. Our analytical frameworks contain blind spots. We're primed to recognize flint tools but might miss a fossilized quantum dot array. This cognitive bias runs deep. Science rightly favors parsimony. But when dealing with deep time, simplest explanation becomes relative. A layer of iridium could indicate an asteroid or a nuclear war. The Silurian hypothesis, named after those fictional reptilian predecessors, flips the script. Instead of hunting for statues or scrolls, Schmidt and Frank proposed detecting civilizations through their planetary metabolism. Our industrial age has left forensic traces. Nitrogen cycles distorted by Haber-Bosch fertilizers, CO2 isotopes skewed by fossil fuels, sediment layers glittering with microplastics. These signals form identifiable patterns, brief, intense perturbations in Earth's geochemical rhythms. The key question: could similar spikes from 100 million years ago survive tectonic recycling? Some markers might persist: chlorofluorocarbons trapped in mineral inclusions, radioactive waste glassified into stable zircon matrices, or nanotechnology residues with unnatural isotopic ratios. The hypothesis isn't about proving ancient factories existed. It's stress testing our ability to read Earth's palimpsest. After all, if humanity went extinct tomorrow, our 300-year industrial pulse would appear in future rock layers as an abrupt 0.000006% anomaly, detectable only to investigators who first imagined such a thing was possible. Our planetary footprint extends far beyond skyscrapers. It's rewriting Earth's geochemical code in ways that will echo for millennia. The Schmidt-Frank analysis identifies 4 forensic categories that could outlast tectonic recycling. Isotopic fingerprints, like the Delta-13C plunge from fossil fuels now permanently etched in Arctic ice layers, create time-specific signatures. While the Petm's carbon spike 56 million years ago mirrors ours, its slower onset, 5,000 years versus our 300-year explosion, helps distinguish natural from industrial patterns. Synthetic molecular ghosts. Our plastics are already polymerizing into future stratigraphic markers, with polyethylene chains persisting up to 2 million years in anoxic sediments. Imagine finding similar cross-linked fluorocarbons in Cretaceous rocks. Would we recognize them as ancient Teflon? Energy waste products. Coal ash leaves telltale cenospheres, hollow microspheres, while nuclear testing implanted global plutonium dust that will remain detectable for 100,000 years. The Oklo natural reactor proves fission byproducts can fossilize. Mass extinction signatures. Our current Anthropocene definition shows distinct patterns. Megafauna vanish first, invasive species dominate, and microplastics permeate even the deepest marine trenches. Similar non-volcanic/non-impact biodiversity collapses in deep time, especially paired with chemical anomalies, could signal lost civilizations. Yet the detection challenge remains profound. Earth continuously recycles its surface. Our best hope lies in ultrastable markers, perhaps synthetic buckyballs surviving in fullerenes, or technetium-99's 210,000-year half-life creating unnatural radiation gradients in ancient strata. The ultimate test may be pattern recognition. Industrial outputs create abrupt, globally synchronous changes across multiple systems, air/water/soil, while natural events typically unfold as sequential domino effects. This multi-proxy approach, combining isotope geochemistry, nanotechnology analysis, and extinction forensics, could one day reveal that we weren't the first to trial and error our way through an industrial adolescence. The Silurian hypothesis confronts us with a fundamental epistemological challenge: how to distinguish nature's handiwork from artificial signatures when all potential witnesses are dust. Consider the Great Oxidation Event 2.4 billion years ago. Cyanobacteria transformed Earth's entire atmosphere, leaving rust-colored banded iron formations, a planetary-scale change mirroring industrial impacts. Without microbial fossils in those layers, we might never have guessed their biological origin. This is the detection paradox. The most durable civilization markers, isotopic ratios, synthetic molecules, are precisely those that mimic nature's stochastic experiments. Our best hope lies in identifying multiple anomalous signatures occurring simultaneously. A carbon spike paired with synthetic fullerenes and nanoscale machining marks in ancient zircons would be harder to dismiss as natural. Yet even these could vanish. Subduction recycles 90% of seafloor sediments every 200 million years, while surface erosion grinds continents down at 1 vertical km per 28 million years. What survives this gauntlet? Perhaps only the most stubborn atomic signatures: plutonium-244's 80 million year half-life, or technetium-99's unnatural persistence. The hypothesis' true value isn't in proving lost civilizations existed, but in exposing our anthropocentric blinders. We're geologic infants. Our entire recorded history spans just 0.0002% of Earth's existence. If a Permian-era civilization lasted 10,000 years, an eye blink geologically, its entire existence would compress into a stratigraphic layer thinner than printer paper. This forces humbling questions. How many industrial adolescences might planets cycle through before one survives? Are we reading Earth's history correctly? Or, like ancient scholars mistaking fossils for stone jokes, are we missing the real story written in atomic imperfections? The search continues not with shovels but mass spectrometers, hunting for statistical impossibilities in isotope distributions or crystalline structures that defy entropic expectations. Whether we find anything or not, the exercise recalibrates our cosmic perspective. We may be neither Earth's first intelligence nor its last, just the only ones temporarily aware enough to ask the question. The vanishing test: remove humanity today, and Earth's recovery begins before our last lightbulb flickers out. Within 48 hours, nuclear plants auto-shut down as safety protocols trigger, while solar arrays keep humming until dust coats their panels. Subway tunnels become underground rivers within weeks as pump failures let groundwater reclaim its territory. London's tube would flood first, its Victorian-era infrastructure already battling 30 million liters daily. By year 1, asphalt jungles sprout real foliage. Knotweed pries apart Brooklyn's sidewalks. Kudzu swallows Atlanta's skyscrapers. And Moscow's GUM department store transforms into a birch forest. The concrete paradox emerges. Our permanent structures decay faster than medieval cathedrals because modern reinforced concrete fails catastrophically when rebar rusts and expands, while stone ages gracefully. After a century, coastal cities face dual assaults. Houston's glass towers collapse into hurricane-driven sediment layers, while Venice's marble palazzos outlast them, their salt-resistant foundations now hosting coral ecosystems. The Anthropocene's most enduring fingerprints emerge. Microplastic layers in ocean sediments concentrate as organic matter decomposes, creating future fossil horizons akin to the Carboniferous coal measures. Plutonium-239 from nuclear weapons testing remains detectable for 100,000 years. Its global distribution pattern, concentrated in 1950s atmospheric test zones, will puzzle future geologists. The ultimate irony? Our landfills may fossilize best. Compacted under millions of tons of debris, certain polymers could persist like Burgess shale fossils, preserving disposable razors and silicone implants as the type specimens of our civilization. Yet within 2 million years, glacial erosion would erase surface traces of even Manhattan's skyline, leaving only odd metal concentrations in strata as clues. This isn't dystopia, its planetary hygiene. Earth has erased 99.9% of all species that ever lived. Why would one recently arrived primate species leave anything more permanent than a chemical whisper in the rocks? The orbital graveyard unfolds first. GPS satellites become derelict tombs tumbling uncontrolled, their aluminum skins pitted by micrometeorites until atmospheric drag claims them within 200 years. Only geostationary sentinels persist longer, their 36,000 km high orbits buying them millennia of slow decay into spectral debris. Earthbound, the great rusting accelerates. Steel-framed towers oxidize into hematite mountains, their collapse timelines dictated by local climates. Dubai's Burj Khalifa lasts perhaps 150 years in arid heat, while Shanghai's humid air devours its skyscrapers in half that time. Plastics undergo photodegradation's paradox. Sunlight shatters polymer chains into microfragments that ironically persist longer as they disperse globally, embedding in sediments from Mariana Trench depths to alpine glaciers. The Anthropocene's most ironic fossils emerge. Underground parking garages become mineralized voids, their rebar corrosion creating unique iron oxide patterns resembling fossilized root systems. By the 10,000-year mark, climate inertia plays its hand. Even without humans, rising seas drown coastal ruins as thermal expansion continues centuries after CO2 peaks. The pyramids of Giza outlast Manhattan not just through stone durability but location. Desert aridity versus hurricane-battered coasts. Fast forward 100 millennia. Only 3 human signatures remain globally legible. Open-pit mines become anomalous geological strata. Sudbury's nickel layers visible like the Cretaceous-Paleogene boundary. Nuclear waste vitrification sites leave telltale radiation halos in bedrock, and Florida's phosphate mines fossilize into bizarre calcium-aluminum-phosphorus deposits. The million-year verdict? Humanity's enduring legacy narrows to subatomic clues. Plutonium-244's alpha decay in ancient concrete, rare earth element spikes at 20th century industrial sites, and perhaps, if we're lucky, a sealed salt mines trove of stainless steel artifacts, preserved like Ordovician cephalopods in their geochemical cocoon. Our ultimate epitaph may be written in radioactive isotopes and polymer fragments thinner than pollen grains. A whisper across deep time saying only, something here once calculated stars. The true fossils of our age won't be skyscrapers or smartphones. They'll be atomic anomalies in sedimentary layers thinner than a hair's width. Picture this, a future geologist analyzing a 100-million-year-old mudstone core stumbles upon a bizarre 2-centimeter stratum. Mass spectrometry reveals a carbon-12 spike matching PTM events, but compressed into just 300 years instead of millennia. Electron microscopy shows perfectly spherical nanoparticles of industrial cerium oxide. Gamma scans detect faint cesium-137 traces, an isotope non-existent in nature, its 30-year half-life proving artificial origin. Pollen analysis shows sudden replacement of diverse angiosperms with monocoque grains. Our wheat and cornfields fossilized. This is how civilizations truly fossilize, not through grand monuments but through planetary vital signs gone arrhythmic. Our most enduring legacies are geochemical vandalism. The 200-plus artificial radionuclides from nuclear tests creating a global marker more precise than any iridium layer, microplastics forming a sedimentary horizon more continuous than dinosaur bones, and the great nutrient spike from synthetic fertilizers altering nitrogen cycles for 50,000+ years. Even our species' extinctions leave forensic clues. Future paleontologists will note the sudden disappearance of large mammal fossils coinciding with strange metal enrichments. Lead from gasoline, platinum from catalytic converters. The terrifying beauty? These signatures don't just persist, they form interconnected patterns. The same layer containing synthetic molecules also shows abrupt changes in foraminifera shell chemistry, ocean acidification, spike fern die-offs, ozone depletion, and exotic metal aerosols, rare earth mining. This multi-proxy assault leaves nature no plausible deniability. Something intelligent and reckless touched this planet. Yet the ultimate irony remains. Our longest-lasting mark may be absence itself. The missing megafauna, the ghostly gaps in coral fossil records, the silent strata where Neanderthal DNA fragments abruptly vanish. These negative spaces scream louder than any pyramid. A testament that on Earth, even apocalypse leaves forensic traces if you know how to read atomic tea leaves. The forensic trail of civilizations reveals itself not in grand ruins, but in atomic whispers, geochemical anomalies that force future scientists to confront an uncomfortable question. Does this pattern require intelligence? Imagine analyzing an Antarctic ice core and finding a 20 ppm CO2 spike compressed into just 3 layers, equivalent to 150 human years. The accompanying platinum anomaly matches our catalytic converter emissions profile. A pollen shift shows abrupt replacement of old-growth forests with cereal crops. This is how civilizations scream across epochs. Not through statues but through synchronized disruptions to Earth's elemental cycles. The real detective work begins when distinguishing our fingerprints from nature's chaos. That carbon spike could be volcanic, except volcanoes don't release radiocarbon-free CO2 like fossil fuels do. The platinum could be meteoritic, but where's the accompanying iridium? The nitrogen surplus resembles wetland emissions, until isotope analysis reveals fertilizer signatures. This multiproxy approach transforms vague anomalies into indictments. When heavy metals, synthetic molecules, and extinction pulses align in time and space, you're not just seeing another Permian-Triassic boundary. You're witnessing a planetary intelligence test gone wrong. The most haunting layers will be the thinnest, the 1945 to 1963 ice strata containing plutonium 239/240 from atomic tests creates a perfect global marker just 18 centimeters thick in Greenland cores. Future geologists might debate whether this represents a natural nuclear reactor like Oklo, until they note its precisely timed correlation with microplastic deposition rates and the last mammoth DNA fragments. This is deep times language. Not chronicles but chemical couplets. Not history books but half-life countdowns etched in stone. To read it requires abandoning human timescales. Our entire industrial revolution compresses into strata thinner than a coin, while the pyramid's construction spans layers barely visible to the naked eye. The real question isn't whether we'll leave traces, but whether any intelligence could ever decipher the story our atoms will tell. The planetary archive speaks in elemental poetry, a language where a 0.1 per thousand carbon isotope shift carries more narrative weight than entire libraries. Ice core chromatographs become time machines, revealing that the 20th century's CO2 surge occurred 100x faster than any Pleistocene interglacial spike. Sediment cores show microplastic concentrations following the exact exponential curve of post-war petroleum production. What makes these signals extraordinary isn't their intensity but their synchronization. The way leaded gasoline aerosols, plutonium fallout, and synthetic nitrogen isotopes all converge in mid-20th century strata like instruments in a dissonant orchestra. The Anthropocene's true signature lies in this discordant harmony. Carbon's double betrayal, simultaneous delta-1,3C plunge and radiocarbon dilution from fossil fuels. The great metal anomaly, cadmium/platinum/neodymium ratios matching industrial byproducts. Pleistocene horizon, polyethylene microfossils outnumbering pollen grains in 2020's lake sediments. Yet nature wears convincing masks. The PETM's carbon release mirrors ours but lacks accompanying technetium-99. Volcanic iridium resembles asteroid dust but comes with telltale sulfur isotopes. The detective's challenge? Separate simultaneous anomalies from sequential events. A civilization's fingerprint requires global synchronicity, identical chemical shifts from Arctic ice to abyssal clay, technological cocktails, impossible isotope ratios plus synthetic molecules, ecological violence, extinction pulses coinciding with geochemical shocks. Even then, the deepest past guards its secrets fiercely. That 54-million-year-old carbon spike with bizarre fullerenes? Could be industrial runoff, or previously unknown mantle chemistry. The late Cretaceous lanthanum excess may be rare earth mining or an undersea hydrothermal freak. This is why the Silurian hypothesis remains science's most humbling thought experiment. Not because it claims predecessors existed, but because it proves how terrifyingly ephemeral intelligence appears at geological scales. Our entire civilization might compress into a 2-centimeter stratum of slightly odd mudstone, a layer future species could walk over without noticing, just as we tread daily atop forgotten Ediacaran seas. The Earth's memory is written in atomic ink that even tectonic chaos struggles to erase entirely. Take the stubborn signatures we've learned to read. Samarium 140 SIXS 103 million-year half-life clocks Precambrian events, while magnetic reversals bisect epochs like punctuation marks. Some anomalies persist through the planetary ringer. The iridium layer from Chicxulub survived subduction forces that grind continents to magma. Yet these are nature's brute force events. An industrial civilization's traces would be subtler, a whisper of technetium-99 in Cretaceous strata, half-life 210,000 years, or synthetic chlorofluorocarbons trapped in fluid inclusions. The real challenge isn't survival but signal-to-noise ratio. When scientists found 28-million-year-old sediment with europium anomalies matching rare earth mining waste profiles, it was filed as unusual hydrothermal activity. A 1970s ice core showing abrupt platinum spikes was attributed to unidentified atmospheric deposition. These orphan data points haunt geology's margins, too precise for chance, too isolated for consensus. The problem mirrors archaeology's old mantra. One odd artifact is a curiosity. A patterned assemblage is a culture. Imagine finding synchronous global lead spikes in Devonian rocks, with correlated carbon isotope excursions.
Plus hexagonal, tungstène, carbide microsphère.
Alone, each permits natural explanations. Together, they scream technology. Yet Earth's archive rarely offers such clean correlations. More often we get fragments like the 56-million-year-old plastic balls in Italian shales, dismissed as fungal remains, or Ontong Java's nickel deposits, exactly where deep-sea mining would occur. Science's conservatism here is a feature, not a bug. Extraordinary claims demand extraordinary contextual proof. But as we're learning from our own planetary footprint, intelligence doesn't announce itself with monuments. It leaks out in atomic irregularities, ecological disruptions, and statistical impossibilities that only computation can unravel. The next revolution in paleontology may come not from shovels, but from machine learning trained to spot unnatural patterns in ancient geochemical datasets, where an AI might recognize what human eyes dismiss as noise. The stone tape recorder never lies, but its playback requires decoding through layers of geological static. Earth's archive preserves atomic truths, a carbon spike here, an iridium anomaly there, while erasing their narratives. The 1874 discovery of Jurassic coal beds, riddled with iron nodules, sparked debates about natural smelting, until modern analysis revealed bacterial origins. Today, we face mirror image mysteries. The Paleocene-Eocene boundaries: mercury spikes, volcanic or industrial, or those bizarre nickel microspheres in Miocene strata, cosmic dust or nanotechnology. The scientific method rightly demands we exhaust natural explanations first, but at some threshold, accumulated anomalies must force uncomfortable questions. Consider the checklist for detecting cosmic-scale intelligence. 1. Synchronous global perturbations across multiple element cycles. 2. Synthetic molecular configurations defying natural self-assembly rules. 3. Energy signatures suggesting entropy reversal, like radioactive waste's unnatural isotope ratios. Our own civilization's most enduring fossils will be these thermodynamic crimes. The trillion metric tons of concrete altering sedimentation patterns worldwide, or the 600-plus anthropogenic minerals like chalconatronite that nature took 4.5 billion years never to create. The real smoking gun, Time compression, when 10,000 years of natural carbon cycle changes occur in a geological eye blink, 300 years for us. Yet permanence is paradoxical. While stainless steel crumbles in millennia, our landfill layers may fossilize into future technofossil strata, discarded iPhones becoming tomorrow's banded iron formations. The ultimate test comes when anomalies form impossible constellations. Finding fly ash cenospheres alongside synthetic steroid hormones in the same Cambrian layer would be like discovering a lit cigarette at Pompeii. Something here violated nature's timeline. We're left tracing Icarus patterns across deep time, not through winged statues, but through sudden plummets in biodiversity curves and the eerie chemical afterglow of played with fire. The forensic trail of civilization fades fastest where we expect it to last, while persisting in ways we rarely consider. Microplastics now form a detectable horizon in 2020's era sediments, their polyethylene chains potentially surviving 100,000 years in anoxic ocean basins. Yet their very ubiquity becomes their downfall as evidence. Without accompanying tool marks or manufacturing residues, future geologists might dismiss them as bizarre bacterial byproducts. Metal artifacts face worse odds. Bronze statues oxidize into unremarkable copper deposits within millennia. Even titanium implants would recrystallize into rutile grains after 10 million years in wet strata. The real longevity champions are our nuclear signatures. Plutonium-244's 80 million year half-life creates an atomic stopwatch, while technetium-99's mere existence, no stable isotopes occur naturally, screams artificiality. But these two face interpretive hurdles. Oklo's natural fission reactor proves nature can occasionally concentrate uranium, while cosmic rays create trace plutonium in mineral deposits. The smoking gun requires context. Finding plutonium-244 alongside microfabricated iridium spheres, like those in catalytic converters, in the same stratum would mirror how we identify meteoritic impacts through iridium plus shocked quartz pairings. Our most enduring legacy may be entropy violations, concentrations of rare earth elements that defy natural fractionation patterns, or the 208 human-synthesized minerals like andersonite that crystallize in precisely the uranium-rich, alkaline conditions of leaking nuclear waste storage. These atomic irregularities form a cryptographic signature no natural process can replicate. A whisper across epochs saying, "Something here once enriched isotopes against nature's gradient." Yet the ultimate irony remains. The very planetary forces that erase our cities, subduction, erosion, may best preserve our nuclear tombs. The concrete sarcophagi of reactor sites could fossilize into future geological oddities, their rebar corrosion patterns preserving the rectangular ghosts of vanished containment walls. The atomic ghosts of civilization whisper through deep time in ways we're just learning to decipher. Take fossil fuel combustion's carbon fingerprint. The Delta-13C plunge we've etched into 21st century ice cores doesn't just record CO2 levels, but carries the specific isotopic betrayal of 300 million years of photosynthetic preference now violently re-released. Future paleochemists spotting this signature in Miocene strata would face an enigma. No known volcanic event matches both the speed, 200 years for our industrial revolution versus 5,000 plus years for PTM warming, and the accompanying radiocarbon void we've created by burning fossilized biomass. Metal concentrations tell similarly damning stories. The 2,000% increase in lead deposition since Roman smelting began creates a stratigraphic spike visible from Greenland to Antarctica, while modern electronics have spread gallium and indium, rare in nature but essential for chips, through wastewater into sediments worldwide. The most tantalizing evidence may lie in unnatural molecular marriages. Neodymium paired with praseodymium in ratios only achievable through industrial separation, or platinum group metals deposited in nanoparticle patterns matching catalytic converter emissions. Even our deepest earthworks leave metabolic traces. China's Three Gorges Dam displaced enough sediment to create a detectable gravity anomaly, while South Africa's 4 km deep mine shafts have permanently altered groundwater chemistry with acid mine drainage that will persist for millennia. Yet the ultimate challenge remains distinguishing our noise from nature's. The 1.8-billion-year-old Oklo reactor proves natural fission occurs, while hydrothermal vents concentrate rare earths without any intelligence required. The forensic toolkit must therefore combine multiple lines of evidence. A carbon anomaly synchronized with metal spikes, synthetic molecules, and extinction pulses forms a signature too statistically improbable for natural chance. Like detectives distinguishing murder from accident, we must listen for the dissonant chord in Earth's symphony, the moment when multiple elemental rhythms fell abruptly out of sync. The Earth's surface is in constant flux. Erosion, sedimentation, and tectonic activity gradually erase even the most monumental human constructions over time. Massive earthworks like quarries or underground tunnels would become indistinguishable from natural geological formations after millions of years. What's fascinating is how our most durable materials behave unexpectedly across deep time. Special formulations like Roman concrete demonstrate remarkable longevity. Their chemical reaction with seawater minerals allows them to endure for 2,000 plus years. Yet modern concrete, vulnerable to internal rebar corrosion, deteriorates much faster. Ceramics and glass become true time capsules, potentially surviving millions of years intact when buried in stable conditions. However, proving their artificial origin would require finding them in distinctive shapes or improbable concentrations. Our most enduring legacy lies not in physical structures but in planetary chemistry. Modern agriculture leaves fingerprints in soil profiles. Fertilizer residues and heavy metal accumulations remain legible for millennia. Deforestation patterns preserved in pollen records, irrigation-altered groundwater chemistry. These changes etch themselves into geological records without our conscious intent. The evidence that might prove a civilization's existence millions of years hence won't be pyramids or skyscrapers, but rather anomalous element distributions in sediment layers, synthetic molecular structures never found in nature, or sudden ecosystem shifts in the fossil record. Like forensic scientists searching for microscopic clues at a crime scene, future paleontologists may need to examine atomic-level traces to detect our presence. The subtle but synchronous convergence of multiple anomalies, chemical, isotopic, and ecological, would form the most compelling evidence that something more than natural processes once shaped this planet. Nature's slow rhythms bear unexpected disruptions, detectable millions of years later only if we know precisely where and how to look. Yet our most fragile traces, books, photographs, digital data will be the first to vanish. Paper burns, hard drives fail, digital signals evaporate when power ceases. Cultural memory, beliefs, and languages disappear far faster than buildings. Within generations, even fundamental truths can become mysteries. So what endures? Very little, yet perhaps just enough. Not a complete story, but a clue. Enough to make some future observer pause and wonder not who we were, but whether we existed at all. Stubborn signals whispering through Earth's strata, refusing to be erased. Now consider how such traces behave in Earth's most dynamic environment, the oceans. For the sea doesn't keep secrets. It dismantles them molecule by molecule. No matter how maritime a civilization might have been, the ocean's corrosive relationship with time leaves little hope. Today's coastal cities, hubs of trade and resources, sit in geologically vulnerable positions. Sea levels have risen over 100 meters in 20,000 years, drowning continental shelves. Ice Age landscapes where humans once lived now lie inaccessible beneath layers of sediment. This makes searching for ancient coastal civilizations nearly impossible. Not because they didn't exist, but because the ocean has systematically erased them. Underwater archaeology faces the ultimate preservation paradox. The very waters that sustained life also ensure its traces won't survive deep time scrutiny. Investigating continental shelves buried under post-glacial sediment layers presents unique challenges. Imagine an ancient civilization developed advanced maritime technology, not just boats, but harbors, ports, perhaps extensive coastal infrastructure. How would these structures fare against deep time? Would decays, ropes disintegrate, stone collapses, and metals corrode rapidly in salt water? Unless quickly buried in oxygen-deprived silt or sand, they'd unlikely survive beyond a few millennia. Even if preserved, detecting them would require targeted high-resolution scanning. Artificial structures might theoretically leave geomorphological traces, straight lines, unnatural angles, repeating seafloor patterns. Yet nature produces remarkably geometric formations too. Most underwater anomalies investigated turn out to be natural. Without contextual artifacts, proving artificiality becomes speculative. Now consider greater impacts. If a civilization didn't just coexist with oceans, but exploited them intensively for waste disposal, mining, or energy generation, modern humans have already imprinted the oceans chemically. Floating plastic continents, mercury in deep-sea fish, radioactive isotopes from nuclear tests, coastal dead zones, microplastics even reach trench bottoms. Had an ancient civilization similarly altered marine chemistry, traces might persist. But distinguishing these from hydrothermal vents, volcanic activity, or organic decomposition signatures would require extraordinary evidence. The ocean both preserves and obscures in ways we're only beginning to understand. Investigating continental shelves buried under post-glacial sediment layers presents unique challenges. Imagine an ancient civilization developed advanced maritime technology, not just boats, but harbors, ports, perhaps extensive coastal infrastructure. How would these structures fare against deep time? Would decays, ropes disintegrate, stone collapses, and metals corrode rapidly in salt water? Unless quickly buried in oxygen-deprived silt or sand, they'd unlikely survive beyond a few millennia. Even if preserved, detecting them would require targeted high-resolution scanning. Artificial structures might theoretically leave geomorphological traces, straight lines, unnatural angles, repeating seafloor patterns. Yet nature produces remarkably geometric formations too. Most underwater anomalies investigated turn out to be natural. Without contextual artifacts, proving artificiality becomes speculative. Now consider greater impacts. If a civilization didn't just coexist with oceans, but exploited them intensively for waste disposal, mining, or energy generation, modern humans have already imprinted the oceans chemically. Floating plastic continents, mercury in deep-sea fish, radioactive isotopes from nuclear tests, coastal dead zones, microplastics even reach trench bottoms. Had an ancient civilization similarly altered marine chemistry, traces might persist. But distinguishing these from hydrothermal vents, volcanic activity, or organic decomposition signatures would require extraordinary evidence. The ocean both preserves and obscures in ways we're only beginning to understand. This dilemma encapsulates what we might call the vanished civilization test. Could a long-lost civilization's technological activities leave traces still detectable today? And if so, would we recognize them as artificial or dismiss them as unexplained anomalies? Consider synthetic molecules. Modern plastics and industrial chemicals don't exist in nature and demonstrate remarkable durability. Some could persist for hundreds of thousands of years under ideal conditions. Fragments might survive in anaerobic seafloor sediments. But the real challenge lies in scale. Isolated fragments prove little. while widespread patterns carry more weight, though they're far harder to identify than discrete artifacts. Heavy metals and rare earth elements tell a similar story. While these occur naturally in volcanic and hydrothermal systems, unnatural concentrations could suggest processing. Yet, distinguishing artificial enrichment requires precise ratios, context, and comprehensive understanding of period-specific background levels. Energy signatures offer another clue. Any complex civilization consumes substantial energy, inevitably leaving waste products, heat signatures, emissions, chemical byproducts. If ancient civilizations used energy sources producing durable residues, radioactive materials, synthetic compounds, these might persist in sediments, but they'd need to appear in concentrations starkly exceeding natural variation. The core problem isn't feasibility of preservation, but interpretation. Such traces wouldn't announce themselves as civilization. They'd manifest as chemical irregularities, subtle deviations in datasets already brimming with natural fluctuations. Like finding a single manipulated pixel in a vast cosmic photograph, the evidence would demand both extraordinary preservation and extraordinary perception to decode. Certain submerged structures appear artificial, yet their origins remain debated. Sites like Pavlopetri, off Greece, or Doggerland, North Sea, relatively recent inundations, reveal only fragmentary, ambiguous traces. These aren't preserved well, but survive by virtue of being shallow and geologically young. As we look deeper into time, the ocean's destructive power magnifies. The seafloor constantly remodels itself. Currents redistribute sediments, marine life transforms surfaces, and corrosion devours metals and concrete. Anything not buried rapidly and deeply succumbs to chemical, mechanical, and biological degradation. This is why submerged cities quickly lose urban characteristics. Even stone structures fail against saltwater, wave energy, and bioerosion. Millennia round sharp edges, dissolve carvings, and disintegrate mortar. What remains blends with natural geology. Collapsed walls become seabed ridges. Ruined buildings mimic rockfalls. For a metropolis submerged 10 million years ago, even one with towering architecture, the ocean would have thoroughly digested all recognizable features. Accessibility compounds the challenge. Most ocean floors remain unexplored. We've mapped the moon more thoroughly than our seas. Current scanning resolutions can't identify small features, especially when degraded or buried. While sonar and submersibles help, they're slow and costly. Some researchers now analyze sediment cores from ocean basins, seeking chemical whispers of lost civilizations in layered mud. These sediment cores function as meticulous time capsules, preserving seawater chemistry, organic matter, and even atmospheric dust particles spanning tens of millions of years. They reveal temperature fluctuations, salinity changes, volcanic eruptions, asteroid impacts, and climate shifts with remarkable precision. Occasionally, they contain peculiar signatures, abrupt carbon spikes, metal-enriched layers, or rare isotope concentrations. Yet none have been conclusively linked to ancient civilizations to date. This absence doesn't prove non-existence, but rather reflects our current interpretive limitations. Should an ancient civilization have constructed coastal infrastructure, discharged waste into oceans, or significantly altered marine ecosystems, chemical traces might persist. However, such signals would need to be dramatic, global, and rapid to stand out against nature's background noise. Consider the 2011 Fukushima nuclear incident. Radioactive isotopes entered the Pacific within days and were detectable off North American coasts within months, a well-documented modern event with known parameters. Now imagine detecting similar evidence 50 million years later, with most material decayed or diluted. Even persistent isotopes would become archaeological ghosts, their origins nearly impossible to decipher. The ocean operates not as passive storage but as an active processor, constantly churning water, nutrients, and sediments through physical and biological systems. Sunken cities don't remain pristine like Atlantean legends suggest. They dissolve, disperse, and become reconfigured within the sea's deep memory. This memory isn't recorded in maps or ruins, but in subtle chemical gradients and morphological transformations. So, when a city sinks beneath the waves and slips from collective memory, does it geologically persist? Likely not in any demonstrable way. Yet these drowned worlds hold profound value, not as evidence, but as stark reminders of complexities. Complexity's startling fragility against time's relentless current. These submerged ruins aren't relics of forgotten civilizations from 100 million years ago. Rather, they serve as warnings, stark reminders that humanity's concept of permanence holds little sway against nature's relentless cycles. Our journey now turns from sea to stone, from what waters conceal to what rock entombs. For while the ocean consumes, geology occasionally preserves. And in rare moments, our planet seems to cling to something it shouldn't, not a structure or inscription, but an inexplicable anomaly that whispers secrets. When scientists examine rock strata, they typically seek coherent patterns that reveal Earth's historical state, climatic conditions, volcanic activity, biological inhabitants. Each layer functions as a page in a planetary ledger, inscribed in minerals and dust. Yet occasionally they encounter misfits, anomalies displaced in time or space. Most eventually yield to explanation, but some linger at science's edges, awaiting new perspectives or technologies. Not all anomalies are mysterious. Geology brims with unusual yet natural formations, mineral inclusions, fossil curiosities, complex layering from environmental shifts. But periodically, discoveries resist easy categorization. Fragments resembling manufactured objects, compositions mismatched with surrounding matrix, or suspiciously regular shapes embedded in stone. The 19th and early 20th century artifact in coal reports exemplify this phenomenon. Miners described finding metal chains, bells, or carved stones within coal seams. Poor documentation and lost samples plagued these claims. Skeptics rightly noted mining's messy nature, coal fractures, collapses, and mingles with modern debris, while confirmation bias distorts perception. These tales endure not as proof, but as cultural markers showing what signals humans consider significant. Similarly, the metallic spheres from South African mines fuel speculation about ancient technology among fringe theorists. Like Rorschach tests in stone, these objects reveal more about our interpretive frameworks than about Earth's hidden history. Their true significance, if any, remains encrypted in deep time's enigmatic grammar. These small grooved objects were discovered embedded in Precambrian rock over 2 billion years old. Research revealed they were likely natural concretions formed by mineral accumulation under extreme pressure, with grooves potentially caused by natural deformation. Fascinating? Certainly. Artificial? Not at all. Such anomalies typically linger at science's periphery. Some remain uninvestigated due to lack of context. Others are dismissed because extraordinary claims rightly demand extraordinary evidence. Most yield to explanation with better data or methods, while a handful persist unexplained, not proven artificial, simply unresolved. This highlights science's cautious nature. It doesn't leap to conclusions, prefers known mechanisms over speculative ones, and demands reproducible evidence rather than oddities. When encountering anomalies in ancient rock, scientists systematically ask, could this occur naturally? Is there contamination? Was the stratum disturbed? Has multiple verification been done? Without clear answers, anomalies remain in limbo. Not all anomalies are physical. Some are chemical, like isotope excursions. Abrupt global shifts in elemental ratios, carbon, oxygen, visible as sharp geochemical changes in strata. Most stem from known causes, massive volcanism, methane releases, or impacts, though mechanisms aren't always fully understood. Some events show rapid warming, acidification, and extinction compressed into thin geological slices. Some researchers have quietly pondered whether such patterns, if found in deep time, could ever indicate intelligence. The answer is usually no, not from impossibility, but because nature suffices as explanation. Intelligence isn't required to interpret most geological records. But what if an anomaly defied all known natural processes? A layer with chemical signatures precisely matching industrial activity, synthetic molecules, peculiar isotope ratios, rare metals distributed globally without volcanic/astronomical sources? That would be harder to dismiss. We haven't found such evidence yet, or perhaps it sits in some database labeled anomalous, awaiting the right question. Ultimately, many breakthroughs come not from targeted searches, but from noticing oddities and refusing to ignore them. The most profound discoveries often begin with someone asking, "That's strange. Why does this exist?" Plate tectonics and the asteroid dinosaur extinction theory were once considered fringe science. The data existed for decades, but only gained meaning when someone connected the dots. Anomalies matter precisely when someone pauses to ask what else they might signify. This illuminates our search for lost civilizations. Any surviving traces likely wouldn't be dramatic monuments or tools, but subtler signatures, unusual mineral deposits, anomalous metal distributions, synthetic molecules in ancient strata. Individually inconclusive, but collectively suggestive. We may have already discovered such evidence without realizing it, interpreting oddities through conventional lenses, weathering patterns mistaken for natural, layered structures dismissed as sedimentary quirks, chemical spikes attributed to algal blooms. Usually correct, but what if occasionally wrong? We can't predict how an ancient civilization would appear in rock strata, or how long its traces might persist. But we know what endures: anomalies, residues, inexplicable patterns where even faint signals must reside if they exist at all. Thus the search continues, not for buried cities, but for potential messages encoded not in words but data, not left deliberately but preserved nonetheless. Now we briefly shift from geology to another record keeper. Not stone, but stories. For sometimes history doesn't vanish, it echoes. The line between memory and myth proves thinner than we admit. When artifacts and strata run out, stories remain, oral traditions spanning generations, sometimes civilizations. Most morph in retelling. Details shift, meanings blur, symbols accumulate layers like geological strata themselves. Yet myths endure. Even when cities crumble and languages vanish, they continue to live on. They are rarely read as literal history, yet more and more, scholars and storytellers alike suggest they may contain fragments of real events. Encoded, altered, but not entirely imagined. This idea is far from new. Across the world, cultures tell of floods, of fire, of stars tumbling from the sky, of lands that once existed but were lost. They speak of golden ages cut short, of forgotten wisdom, sudden darkness, strange visitors, islands swallowed by the sea. Read alone, each tale seems symbolic, almost fictional. But taken together, they reveal patterns, shared fears, shared experiences, and perhaps shared memories of events long before writing existed. Among the most enduring motifs is the flood. It appears in Sumerian, Babylonian, Greek, Hindu, Norse, and biblical traditions alike. Details differ, but the essence remains. A vast deluge sweeps away an earlier world, often as judgment or as renewal. Sometimes survivors are warned, sometimes they build vessels, sometimes they climb the highest peaks. One can dismiss these stories as metaphor, seasonal rains, the fragility of human life. Yet geology tells another story. At the end of the last ice age, glaciers melted, seas rose over 100 meters, and whole coastlines disappeared. Those who lived along those shores saw their world vanish, and perhaps their descendants preserved it in myth. Other traditions speak of lost lands: Atlantis, Mu, Kumari Kandam, High Brazil. They are remembered as beautiful, advanced, fated to fall. The causes differ: hubris, war, divine punishment, but the endings are always the same. The land sinks, the people vanish, the tale survives. Today, many regard them as allegory or folklore, but even fiction can preserve echoes of reality. A drowned land may indeed have existed, even if its details are blurred. And then there are the myths of lost knowledge. Many cultures insist there was once a time of greater wisdom, when humanity understood the stars, shaped the earth, and lived in harmony with truths now forgotten. These accounts are not proof, but they raise a question. Why do cultures believe they once knew more than they do now? Not all traditions share this belief, but those that do remind us of how deeply and mysteriously human memory endures. But in some traditions, the fall described is not only moral, it is also a collapse of knowledge, of skill, of connection to something greater. And then come the peculiar accounts in ancient texts. Tales of machines, flying craft, cities in the sky, and weapons of unnatural power. Most of these are clearly symbolic. Yet at times the descriptions become strangely detailed, so specific that some argue they cannot be dismissed as mere invention. Supporters of the myths as memory perspective suggest that such stories may be distorted echoes of real events or technologies, passed down through oral tradition long after their context was lost. Testing this scientifically is nearly impossible. Myths are not evidence. They carry no dates, no stratigraphy, no calibration, but they remain part of the human record. And when cultures with no known contact tell similar tales, it raises a question worth asking. Modern anthropology and archaeology have returned to this puzzle, not to search for ancient astronauts or lost continents, but to understand how oral history functions, how stories are preserved, reshaped, and transmitted across generations. In some indigenous traditions, oral accounts have proven astonishingly accurate when compared with archaeology and environmental studies. Entire landscapes, rivers, glaciers, volcanic eruptions, have been described in story centuries before any written record. This suggests myths are not pure fantasy. They are compressed histories, molded by culture and language, yet grounded in lived experience. They may be filled with metaphor, yes, but metaphors of something. And sometimes, with patience, those metaphors can be decoded. None of this proves that an ancient civilization existed, but it challenges the idea that history begins only with writing. The absence of script does not mean the absence of memory. For while material evidence is fragile, stories can endure for millennia. Myths may not tell us exactly what happened, but they remind us that something happened, and that it mattered enough to preserve in the only medium available. Which brings us down to the earth itself, to the fragments we have unearthed. Not myths, not metaphors, but matter objects with weight, texture, and form. Some ordinary, some strange, and some that raise just enough questions to keep curiosity alive. Take tektites, for example. Small, dark, glass-like fragments, aerodynamic in shape and strikingly uniform in composition. Most geologists agree they are the product of impact events. When a meteorite strikes, melts the ground, and hurls droplets skyward, cooling into glass as they fall. In isolation, they are fascinating but not mysterious. What becomes intriguing is how such materials, tektites, metal shards, worked stones, are woven into stories that stretch far beyond geology. Tales of lost knowledge, vanished builders, and tools where no tools should be. Most of these claims collapse under scientific scrutiny. Yet the artifacts themselves are real. Not alien, not supernatural, just difficult to classify. Many sit quietly in museum drawers, misfiled or unanalyzed, not due to conspiracy, but because science tends to move on when evidence refuses to fit neatly. This is why the so-called out-of-place artifacts, or OPArts, continue to attract attention. Objects that appear in geological layers predating human history, lingering at the boundary between anomaly and explanation. Examples often cited include metal spheres found in billion-year-old rock, carved objects within coal seams, or items embedded in stone that look as if they were machined. Nearly all of these cases have been explained away as misidentifications, hoaxes, or natural formations. Yet the persistence of these stories tells us something, not necessarily about ancient machines, but about humanity's hunger for another story. One in which civilization did not simply begin 10,000 years ago, but has risen and fallen many times before. At times, the artifacts themselves are genuinely curious. A polished stone ball with near-perfect symmetry, a copper implement discovered in strata deemed too old for metallurgy, or a carved design found deep in caves thought unreachable by known cultures. In almost every instance, plausible explanations exist. Geology can produce astonishingly regular forms. Chemical weathering can carve stone into strange shapes. Artifacts can migrate between layers through animal burrows, groundwater shifts, or human error during excavation. Even if none of these objects turn out to be the long-sought smoking gun of a forgotten civilization, they highlight an important truth. The deeper into the past one looks, the harder certainty becomes. Sediments churn, caves collapse. Dating techniques depend on context, and context can vanish. If a technological object were uncovered in a 10-million-year-old layer, utterly unlike anything known, we would almost certainly attribute it to contamination or intrusion. Most of the time, that judgment would be correct. But such caution, while statistically sound, can make us blind to the rare instance when it might not be. Tools, after all, can endure under the right conditions. Stone tools, in particular, are remarkably resilient. We have discovered flaked flints more than 2 million years old, showing deliberate shaping, use wear, and clear signs of cultural transmission. What is striking is that it took archaeology a long time to recognize these as tools. For years they were dismissed as geofacts, naturally broken stones. Only when patterns appeared, repetition, clustering, where marks, did the scientific community accept their human origin. This offers a direct lesson for the search for any non-human civilization. The first evidence would not be sprawling cities or complex machines. It would be subtler patterns, tools that do not align with local geology, arrangements of material that suggest planning, regular shapes recurring too often to be mere chance. But such signs are deceptively easy to miss, especially without context. And context is fragile. Imagine uncovering a perfectly shaped sphere in rock dated to 100 million years ago. The immediate conclusion would be that the layer had been disturbed, that the object was intrusive, and perhaps it was. Yet if we dismiss every anomaly that doesn't fit the accepted timeline, we also dismiss the possibility of discoveries that might change that timeline. Then there are the tall tales, stories passed down or published in fringe journals. An iron nail in sandstone, a mechanical device encased in coal, a human footprint beside a trilobite. Almost without exception, such claims unravel under investigation. Poor documentation, missing specimens, obvious tampering. But not all are hoaxes. Some come from earnest observers without the training or tools to interpret what they saw. And some are simply mistakes, natural features mistaken for artifacts in the moment. Still, the underlying idea that something came before us is not inherently wrong. What usually fails is the evidence presented. But the impulse is understandable. People long to believe that history runs deeper, that our story is part of a longer, more complex arc. And in truth, that belief is not only hopeful, it's logical. Intelligence is not a one-time event. It is an emergent property. Over billions of years, it is reasonable to ask whether it has appeared more than once. Science, of course, requires more than curiosity. It demands data, repeatability, rigor, but it also requires questions. And many of the best questions begin with outliers, things that do not fit. Most anomalies dissolve under scrutiny, but a few open new doors. So even if tektites are nothing more than splash-formed glass, even if the tools belong to known species, even if the tall tales are only legends, they still matter. They remind us to look more closely, to consider what may have been overlooked, and to accept that the line between natural and artificial, between coincidence and pattern, is not always clear. Next, we step further into that uncertainty, because not every intelligent culture would have developed along the same path as ours. Not every civilization would have chosen stone or metal, and if some never did, their traces, if they still exist, might be so subtle that we've walked past them countless times, unnoticed, unmarked, but not entirely erased. When we picture a civilization, we instinctively imagine certain things. Tools, buildings, machines, writing, monuments, and almost all of them are shaped from or built with metal. Metal is central to how we define technological progress. The Stone Age, the Bronze Age, the Iron Age. But that framework assumes one path, one model, one ladder. In reality, metal is not required for intelligence, nor even for complexity. It is simply what we used. So what if another civilization never reached for it? What if it grew, flourished, and disappeared without ever smelting a single piece of ore? The idea is not far-fetched. For most of human history, we lived without metal. Early humans crafted stone tools, worked wood and bone, mastered fire, understood animals, made clothing, decorated homes, and built rich oral traditions. All of it without metallurgy. Even today, many indigenous cultures have thrived with little or no metalworking, long after encountering societies that relied heavily upon it. Complexity does not begin with smelting. It only becomes visible to archaeologists because of it. If we consider the possibility of a pre-human or non-human civilization, we must ask, what would their record look like if they never entered a metal age? The short answer, it would be nearly invisible. Organic materials, wood, fibers, hides, even bone, decay quickly unless preserved in very dry, frozen, or anaerobic conditions. Textiles rot. Wood burns or decomposes. Leather disintegrates. Without stone, metal, or ceramic to carry the memory of those objects, almost nothing endures. And even when preserved, Organic remains are rarely recognized as technological unless the shaping is obvious. A bundle of fibers could be string or roots. A hollowed trunk could be a canoe or just a fallen tree. Now imagine a civilization built entirely from biodegradable materials. Shelters woven from plants, tools carved from hardwood, containers of gourds and leather, decorations of feathers, bark, pigments, smoke, and sand. Symbols written not on stone or clay but on perishable surfaces. Nothing mined, nothing smelted, nothing left behind to rust or fracture into enduring fragments. In the right climate, such a society could flourish for thousands of years and yet leave almost nothing in the geological record that we would recognize as civilization. A forest could reclaim the traces of a civilization in just a decade. Erosion could erase the rest, and in a million years nothing would remain. Even fire, one of humanity's oldest and most transformative technologies, does not preserve well. Charcoal layers, ash beds, fire-cracked stones can be found, but these are also common in nature. Lightning, wildfires, volcanic eruptions all leave similar marks. To distinguish fire used with intent from fire born of natural forces, you need context, hearths, patterns, associated artifacts. Without those, it's just another dark layer in the soil. Some non-metal tools might endure, especially stone. But not all stone tools are obvious. A pebble used to grind grain or soften fibers may never be shaped. A sharp rock used for cutting may not be retouched. If tools are not curated, stored, or reused, they fade into the natural background. And if their use leaves no lasting wear patterns, identifying them later is nearly impossible. It's also possible for a civilization to achieve high levels of knowledge, astronomy, agriculture, even medicine, without ever needing heavy industry. Knowledge isn't always tied to material excess. A society could map the stars with naked eye observations, track the seasons with stone or wooden markers, breed plants through careful selection, measure time with water, compute with knots or beads, and pass wisdom through encoded songs. None of these demand metal, only continuity. And if continuity is broken by disaster, disease, or migration, knowledge can vanish as swiftly as the tools decay. Language is especially fragile. Spoken words die with the speaker. If not written or carved, they vanish entirely. Even writing isn't secure. Paper burns. Bark and leaves rot. Inscriptions on sand, wood, or pigment disappear unless deliberately preserved. A civilization that never developed a durable script or never needed one might leave no trace that it ever existed. And then comes the matter of scale. Not every civilization builds cities. Some remain mobile. Some integrate seamlessly with their ecosystems. Some value impermanence. Our definition of advanced is biased toward what leaves large footprints. Architecture, pollution, energy use. But those are cultural choices, not inevitable stages. A society could be technologically sophisticated, even philosophically refined, yet choose to live in ways that minimize its geological impact, especially if it learned, through experience or collapse, that high-impact lifestyles lead to ruin. In that case, what signs would remain? Perhaps reshaped landscapes, terraced hillsides, altered river courses. Perhaps plant species growing far from their native origins. Perhaps evidence of fire management, enriched soils, or intentional patterns of biodiversity. But these traces are subtle, so subtle they vanish into natural processes and are easily overlooked or mistaken for chance. We already see this in our own world. The Amazonian terra preta, the dark, fertile soil enriched by ancient communities, is still not fully understood. It holds charcoal, bone, pottery shards, and organic matter, arranged in patterns that suggest deliberate engineering. Yet it doesn't look like a city. It looks like dirt. For centuries, it was dismissed as just another soil type. Only now are researchers beginning to realize it may be the legacy of a complex, organized society with profound agricultural knowledge and mastery over the landscape. Now imagine, if something similar had happened 100 million years ago. Fewer pots, fewer stone tools, structures made entirely of biodegradable materials, it might never be noticed at all. Especially if it lay now beneath the sea, eroded away, or swallowed by tectonic shifts. Civilizations without metal may not be lost because they failed. They may be lost because they succeeded, because they learned to live lightly, to blend with their environment, to value cycles over monuments. From the standpoint of preservation, that kind of success becomes invisibility. We tend to think of progress as a trail of artifacts. But the absence of artifacts is not always absence. Sometimes it's a choice, a reflection of different priorities, or simply the work of time which never promised to keep our records safe. What remains, then, is silence. Not just the physical gaps, but the deeper uncertainty. For even with all we know about geology, archaeology, and history, there are still places where nothing speaks. And that silence may be telling us something, or concealing something that once was. Soil holds memory. It records what grew, what died, what burned, what passed. Sometimes holds footprints. It absorbs blood, ash, rain, decay. But it does not shout its history. It whispers, and only in fragments. With the right tools, you may uncover a story. More often, you find silence. And in that silence, we begin to realize how fragile the record of a civilization truly is. We think of soil as surface. But in many ways, it is an interface, a threshold between the living and the non-living, between biology and geology. Every leaf that falls, every creature that dies, every root that pushes through is shaping the layer beneath our feet. Over time, those layers compress, turning to sediment, and if buried deep enough, to stone. But most soil doesn't endure that long. It is overturned, eroded, carried away by wind and water. The traces that do remain are rare, and those that survive often reveal very little on their own. Still, there are places where soil carries a distinct imprint of past life. Ancient hearths leave behind charred residue. Collapsed homes leave organic stains. Burial sites reveal patterns of human activity, discoloration, disturbed layering, chemical shifts from decayed bodies and offerings. Yet these signs are fragile. A few thousand years of weather or agriculture can erase them entirely. On geological timescales, they survive only in rare, stable environments, frozen tundra, arid deserts, peat bogs. This is why most ancient civilizations are traced through stone and metal, not soil. Soil without its context doesn't endure as evidence. Stripped of that context, it stops telling a story. It becomes noise or nothing at all. Researchers, however, have begun to refine ways of reading this silence. Archaeobotanists analyze pollen, phytoliths, and seeds to reconstruct ancient landscapes. Geoarchaeologists examine soil chemistry, texture, and layering to infer human activity. Blackened soils may indicate controlled burning. Phosphate concentrations may point to habitation or waste. Unusually fertile patches may suggest long-term cultivation. Yet each of these signs requires interpretation. High phosphate isn't proof of settlement, it could come from animals. Dark soil might be a hearth or a lightning strike. Charcoal-rich soil could be the product of deliberate enrichment, or simply the aftermath of a wildfire. And so, when we ask whether another civilization might have existed deep in time, we must face a hard truth. Soil alone will not confirm it. Not after millions of years. Even if such a society once shaped landscapes, grew crops, built homes, altered ecosystems, those changes would almost certainly have been reabsorbed, turned over, washed away, compressed, or erased. It is a difficult truth to face, that an entire civilization, its knowledge, its cities, its memory, could vanish so thoroughly that even the very ground beneath it forgets it ever was. That is the nature of time. Not cruel, not kind, simply indifferent. If nothing resists, nothing remains. And soil, as a medium, offers little resistance, cooperates, it recycles, keeps the cycle moving. There is another problem. Even if some residues survive, how would we know they weren't natural? How do we tell an ancient garden from a wild meadow, a fire pit from a scorched patch of ground, a footpath from an animal trail? The further back we look, the less those distinctions hold. At a certain point, activity and accident blur into the same thing. And what survives is not always what mattered most. Stories don't fossilize. Relationships don't appear in soil cores. Songs, rituals, ideas, they leave no chemical trace. Even when objects endure, their meaning often does not. We've uncovered tools we don't fully understand, languages we cannot read, symbols we cannot decode, and those came from civilizations we know existed. The gap left by an unknown one would be even wider. So when we sift the soil for answers, we must be honest about what we seek and what we're prepared to recognize as meaningful. A strange chemical spike, an unusually fertile patch, a layer of char in an unexpected place. Are these signs of intelligence or just noise? The line is blurred, and in deep time almost invisible. But silence itself is an answer. It shows us that even intelligence, even culture, can vanish without leaving a trace. The earth does not distinguish between life shaped by instinct and life shaped by thought. Unless something durable is left, something strange, unmistakably artificial, it will be lost, folded back into the cycle, another layer, another shade in the soil. From here, we turn from silence to speculation. Not what we might find if another civilization existed, but what they might find if we disappeared. Because imagining how our own world might look from the future is the clearest window into what traces a lost one could leave behind. If humanity vanished tomorrow, the world would notice immediately. Cities would fall quiet, lights would go dark, planes grounded, roads empty. But in geological time, that silence would not last. Our absence would register for a moment, then dissolve. The real question is, what part of us would remain? Some signals would be unmistakable. The chemical makeup of our atmosphere, for instance, is already shifting in ways visible in ice cores and ocean sediments. Carbon dioxide is spiking at rates unseen in millions of years. Methane concentrations are rising. Nitrogen cycles have been altered by fertilizer use. These changes are global, synchronous, sharp, unnatural breaks in long stability. Even without knowing the cause, future geologists would see that something extraordinary happened in our era. Plastics are another marker. Synthetic polymers are being deposited everywhere. Landfills, rivers, oceans, even mountain snow. Microplastics are turning up in marine sediments, in fish, in human blood. They resist decay, and even when fragmented, their chemical fingerprints persist. Future researchers would see sudden, planet-wide bands of plastic-rich sediment. They would stand out, not because plastic is indestructible, but because it is alien to Earth, a layer made of things the planet never made on its own. And beyond that, our industries are altering the planet's mineral record. Fly ash from coal, slag from smelting, fragments of concrete, synthetic pigments, artificial alloys, all etched into stone, all lasting far beyond us. The technofossils we are creating today are already being sealed into concrete or buried in landfills. In the deep future, they may appear as strange inclusions in sedimentary rock, sharp-edged fragments with element ratios that nature never assembles on its own. Another marker is radiation. Mid-20th century nuclear testing scattered isotopes like cesium-137 and plutonium-239 across the globe. These isotopes decay at predictable rates, yet they remain measurable in soil, ice, even in animal bones. The radioactive fingerprint of that brief but intense era could endure for tens of thousands of years, perhaps longer in protected environments. To a future observer, it would look like a sudden burst of radiation without any natural cause. Our cities, ironically, would not last. Above ground, neglect would collapse buildings within decades. Steel rusts, concrete fractures, glass shatters, rebar expands, roots pry open foundations, and moisture seeps into every crack. Within 1,000 years, most structures would be unrecognizable, buried, eroded, overtaken by forest or desert. After 10,000 years, one would have to dig to find anything at all. Only in rare cases, where floods, landslides, or volcanic ash rapidly entombed urban layers, might intact remains survive long enough to fossilize. And even then, they would crumble into jumbled debris, stripped of shape and meaning. Underground, some constructs might endure longer. Subways, bunkers, mines, waste repositories, anything sealed away in geologically stable regions could persist. Future excavators might stumble upon odd chambers filled with unknown materials, or corridors carved with uncanny precision. But without records, without context, they too would be baffling. A data center might appear as a cave, a missile silo as a mineral-lined natural void. Our machines wouldn't fare much better. Cars, phones, planes, satellites, metal corrodes, wires decay, plastics fragment. Buried in sediments, a few pieces might last. Engines fossilized in place, circuit boards transformed into mineral composites. But most of our technology was built to function, not endure. Once its function is gone, its form soon follows. Our data is even more fragile. Magnetic drives lose coherence, optical disks degrade, solid-state memory cannot hold charge forever. The vast library of our knowledge, books, films, digital archives, would vanish unless saved by accident. Carved stone might last. Etched metal plates might survive. But the rest would fade into silence. But hard drives almost certainly wouldn't survive. Our entire digital culture could become a blank spot in the sediment, detectable only through the chemical shifts happening while we lived. Agriculture, however, might leave longer-lasting traces. The global reshaping of ecosystems, cleared forests, terraced fields, monoculture plots, has altered erosion patterns, soil chemistry, and even plant evolution. Thousands of years from now, fossilized pollen might reveal the sudden dominance of just a few species. Deforestation patterns could leave unusual carbon signatures in sediments. Future botanists might deduce widespread cultivation. Still, without tools or texts, the story is incomplete. Agriculture without farmers or domesticated animals leaves limited marks. Bones could cluster around ancient settlements. Dogs, cattle, sheep, pigs, all genetically distinct from their wild ancestors. Fish farms and livestock facilities might leave dense remains. Chemical signals trace antibiotics. If sediment locks them quickly, those bones could last tens of thousands of years, perhaps longer. Fossil fuels are another indicator. Massive extraction and combustion of coal, oil, and gas leave traces not only in the atmosphere but in soils and waters. The isotopic signature of burned fossil carbon is already detectable. In some future rock layer, this shift will appear sharp. Compressed into a few centimeters of sediment, it will signal a planet out of balance. Rising greenhouse gases, warming temperatures, acidifying oceans, a pattern never seen before, and possibly, if we vanish, never to be seen again. So what will we leave behind? Not monuments, not stories, but chemistry, isotope ratios, artificial molecules, strange minerals, spikes in carbon, drops in biodiversity, a line in the rock, a signature sharp, fast, and global enough to indicate intelligence. A civilization that built, burned, and buried itself in its own record. And for any observer millions of years from now, that might be enough to know we existed. Perhaps even enough to wonder what happened. Now let's flip the question. If something existed before us, if an earlier intelligence rose and fell long before humans appeared, where is their trace? If the silence is proof not of absence but of erasure, what would it take to leave no mark? And how likely is it that someone already has? If a civilization lived millions or tens of millions of years ago, the pressing question isn't how they lived or what they made. It is this: where are they now? Not just physically, erosion, subduction, and decay can explain that, but historically, narratively. If they were here, why is there no memory, no whisper, no lineage? Did they truly vanish? Or did they transcend in some way, reaching a state beyond our comprehension? Or perhaps they simply ended, leaving behind a record too faint for us to perceive. The Earth is not a forgiving archive. It is an active, ever-moving, constantly cycling planet. Plate tectonics grinds the oldest crust into the mantle. Erosion flattens mountains and spreads dust across oceans. Forests rise and fall. Deserts shift. Rivers redraw the land. Even without catastrophic events, the planet alone is enough to erase nearly everything a civilization might build over enough time. The disappearance of physical artifacts is only part of the issue. The deeper question is why there is no clear cultural thread. No myths unmistakably pointing to a pre-human intelligence. No traditions preserving their knowledge. No visible break in the evolutionary record suggesting intelligent intervention or artificial alteration. In short, no clear evidence that anyone like us existed before us. One answer is scale. Human civilization, as we know it, spans just a few thousand years. Agriculture is about 12,000 years old, the industrial age 200, the digital age only decades. And yet, in that brief window, we've reshaped the planet. Now imagine a civilization lasting 10,000 to 20,000 years, but 50 million years ago. What would remain? At most, a few sediment layers. Unless they seeded life, altered genomes, or left durable, unmistakable artifacts, their influence could easily blend into natural records. We often imagine intelligence as cumulative, self-building, leading inevitably toward greater complexity. But that is a projection. Evolution doesn't guarantee continuity. A species can vanish in a single generation. A culture can collapse in a few seasons. Complexity is no shield. Lost intelligence does not ensure a second chance. They could have ended suddenly. A war, climate event, runaway technology, or simply the slow attrition of stability. Depleted soils, lost species, systems too interdependent to adapt. If they collapsed, populations might have dropped rapidly, scattered, regressed, disappeared. With no one to preserve knowledge, memory fades. Language unravels. Stories fragment and dissolve. Or perhaps they simply withdrew, not necessarily into space, but into silence, minimalism, a way of life that consciously chose to stop expanding. Maybe they recognized limits. Maybe they avoided monuments, chose blending over expansion, and gradually faded from the physical world without disaster or regret. Not a fall, but a release. Perhaps they erased themselves so thoroughly that we would never know they existed. There's also the unsettling possibility that they didn't live long enough to leave a story. Intelligence may have flickered briefly, never reaching critical mass, wiped out before memory could form. Not every spark becomes a fire. And in a world full of predators, natural hazards, and biological risks, a species could gain consciousness but not culture, culture but not civilization, civilization but not resilience. If we ask where they went, we must also question what we assume they were. Were they like us, bipedal, tool-using, language-speaking, or something stranger? Tree-dwelling octopus minds, oceanic collectives, networked intelligences? Intelligence does not have to resemble primates building machines. It could emerge in forms that leave no traces we know how to detect. So maybe we're asking the wrong question. Not where did they go, but what were they to begin with? Even if they existed and left some mark, recognizing it would demand that we step far outside our assumptions. We would need to notice absences rather than artifacts, disruptions rather than ruins. Traces might lie not in rock or metal, but in genes, sediments, isotopes, patterns that defy natural processes yet don't scream machine. Maybe they didn't go anywhere. Maybe they folded into the biosphere, recycled into dust, code, and cells. Perhaps we've walked through their cities without realizing it. Maybe the silicon in our microchips was once the foundation of their homes. Their legacy may not be gone, only scrambled, diluted, repurposed by Earth's relentless metabolism. Perhaps in some form they are still here, not biologically, not consciously, but embedded in the systems they left behind. Reshaped ecosystems, redirected rivers, modified genomes, structures too ancient to label, too strange to claim. They don't announce themselves because we are no longer the intended audience. The deeper we dig, the more we realize that loss is often silent. Endings don't always come with warning. Disappearance, especially on a planet like this, can be complete. Next comes a harder question. Not whether a past civilization existed, but whether we would believe it if we found evidence. Knowledge is not just data, it's recognition. And belief, when rewriting the story of who came before us, is always the hardest part. Humility is not demanded by science, but enforced by the universe. Every time we assumed we were central, we were moved outward, first from Earth, then the Sun, then any special place in the galaxy. Now, looking at Earth's deep past and asking if we were the first to reach this awareness, we face a new kind of decentering. Intelligence might not be unique. It might arise multiple times and vanish so completely we wouldn't notice. Not because it left no traces, but because we've explained them away or never saw them. We assume important events would be obvious, but permanence is not normal. Most human history, even from the last 10,000 years, is lost. Entire cultures left no records. Entire cities left no ruins. How much more could be missing from 10 million or 100 million years ago? The geological record is not a book. It's a puzzle missing most of its pieces. Only pieces that sharply contrast with the rest catch our attention. Strange things are noticed. Subtle ones fade into the background. This is why pre-human civilizations are so hard to study. Not because the idea is absurd, but because it exists where evidence is weakest and interpretation is most fluid. Science must allow room for doubt without abandoning rigor. Unknowns must not be filled with fantasy. Most scientists resist the idea not out of arrogance but training. Extraordinary claims require extraordinary evidence, and so far there is none. No machine parts in rock, no coded messages in carbon layers, no structures requiring intelligence and excluding all natural causes. But absence of evidence is not evidence of absence. Time can be so vast that silence dominates. Not because nothing happened, but because the earth forgets well. Here humility returns, not surrender, but honesty. We don't know if we're first. We may never know. And if we aren't, we may never find proof. Even if we do, we might not recognize it. As we map anomalies, study extinction events, trace chemical signals through sediments, we are constrained by what we expect to see. Buried cities, spikes in rare elements, fires, meteors, patterns unfamiliar to us require effort to detect. This limitation is not just scientific. It's emotional and cultural. If something like us came before and disappeared, it reshapes what we consider inevitable. Progress becomes fragile. Civilization brief. Intelligence less a crown than a possibility. It may come, go, return, or not. And meaning remains. If someone came before us, built, dreamed, wondered, failed, what does that mean for us? Less special? More connected? Their continuation? Or our replacement? Repeating their mistakes? Or forging a path they never walked? We don't know. That uncertainty is essential. The most enduring legacy of a prior civilization may be conceptual. The very notion that they could exist, that we might not be first, and that someday someone may ask the same about us. What will they see? Carbon spikes? Scattered plastics? Brief glimmers in sediment? Will they call it civilization, tragedy, proof they are not alone? We imagine the past as something fixed, but it isn't. The past shifts each time we look at it with new eyes, new tools, new questions. And the question of lost civilizations is not really about history at all. It's about how much mystery we can live alongside. How much wonder we allow into our picture of the world. Not every riddle asks for a solution. Some only want to be acknowledged. And this one, perhaps more than any, asks not for belief but for attention. So we bring this journey to its close. Not with an answer but with a pause. Because despite all the asking, all the speculation, the night still holds more than we can grasp. And maybe, for now, that is enough. After all the wandering through stone and memory, we arrive at a quiet edge. What we carry isn't certainty, but stillness. And in that stillness, something soft unfolds. The question eases, not because it is solved, but because it has been heard. Maybe we are the first. Maybe not. Maybe intelligence is rare. Or shy. Perhaps it blooms in hidden corners and fades before leaving a mark. Perhaps Earth has carried more minds than we will ever know. Each one flickering awake, shaping its age, then slipping quietly beneath the next layer. We search because that is what minds do. Not only to find, but to reach through time, through space, through possibility. The same curiosity that sends probes to other worlds sends thoughts into the past, asking who else might have stood here, looking upward, wondering, listening. And you, right now, wherever you are, whenever it is, are part of that search. A thread in the long weave that ties questions to silence, silence to story. Even by listening, by following this trail through the dark, you are part of something profoundly human, or perhaps more than human, something conscious, something universal. Because sleep, too, is a kind of deep time, a letting go of the surface, a sinking into hidden layers. And tonight, as you drift into that silence, perhaps the minds that came before, if they came at all, will meet yours in passing. Not with answers, but with companionship. So rest now. Not because the questions are finished, but because you've carried them far enough for one night. The past will wait. The earth will keep spinning. Whatever came before, whatever comes after, you are here now. Sleep well, time traveler.